Hello all, welcome to 8085 microprocessor tutorial. First, we'll try to understand you about 8085 microprocessor 8, what are its data, what are its addresses, and then we'll move on to the basics ALP program that will be helpful for you all to understand 8085 microprocessor better. So, starting with 8085 microprocessor kit, the most basic thing that is required to understand about ALP is how much data you can be performing on that. So 8085 microprocessor has 8-bit data line and 16-bit of address line. You might know it will be from D0 to D7 and this will be from address A0 to A15. So as it is 8-bit data, the maximum range can be 2 power 8, that is 256 in decimal, and similarly 2 power 16, that will be a 65536 in decimal. So coming it to its range, we'll say 0 to 255 in decimal, and that will be 00 to FF in hexa. Similarly it will be 0 to 65535 in decimal, and it will be from 0000 to FFFF in hexa. So this is the basic thing about 8085 microprocessor in order to understand any type of program what is written and all. See, machine only understand either two things, that is either 0 or 1. There are n number of ALP instructions that we are familiar with, say move and all. There are the English language that we are familiar with, but the machine only understands 0 and 1. So if we say MVIA03H, meaning move the data, immediate data 3 in register A, but machine won't understand what MVIA. So for it there is a opcode written for 8085 microprocessor. That opcode will be 3E. That a seat will be given to you. So just you need to understand what MVIA instruction does, and then opcode will be given over in the 8085 microprocessor. Mostly in the kit only the picture has been put up, so you don't have to mark it up. But what does it mean? MVIA is move immediately data to register A. So this will be the basic of 8085 microprocessor, and let us start with basic program, say addition of given 2 bytes. I hope you are familiar with the addressing modes that are used in 8085 microprocessor. There are basically 5 types of addressing modes. Immediate data, that I've given example of MVIA and all. Then it will be a direct addressing mode, indirect, implied, and then register addressing mode. In example itself we'll be understanding and we'll be distinguishing what will be the different types of addressing mode. So let us start with, say you have 2 data 3 and 2 that you need to perform addition of. But first I'll make sure that the 3 and 2 which data type you are using, either you are writing in decimal or in hexa. In 8085 microprocessor by default there are data are written in hexadecimal. So if you are trying to add any of the data, get the data in decimal, then first you need to convert into hexadecimal in order to put it into 8085 microprocessor. Here 3 and 2 both are in hexadecimal, so I am not worried. If I add also 3 plus 2, the result will be 5, and let us check whether it happens or not. So first for that 3 is the data and 2 is the data, so I need to take 2 registers A and B, where I will just copy the data into A and copy the data into B, and then perform addition between these two. So all I do is MVI A03H, MVI B02H, and then just perform add B. And then what I'll do, after adding, I'll try to store whatever the result is in the accumulator in some address, say 2050H, and then terminate the program. Now I have written this. Let us understand what does actually the program does. This means data 3H is being copied or moved into register A. And what does this do? Similarly, the data 2 is being copied into register B. And what does this do? A equals to A plus B. Now the resultant is stored in accumulator. So I need to store the data of accumulator in some address. So I have taken the address as 2050, and after performing the addition, I'll just terminate the program using halt. Now this is the basic ALP program. But in order to perform in 8085 microprocessor kit, I need to know the starting address, where I am studying the address from, and then corresponding opcodes which machine understand, and then instruction. And one more term I need to introduce is called T states. What is T states means how much clock period does it require to complete one set of instruction. So I'll write first instruction is MVIA03H and say starting address to be 2000. The opcode for MVIA is nothing but 3E, and the data that need to be written in 2001. Why? Because already explained in last tutorial that opcode for any 8085 microprocessor, the data's maximum bit is 8 bits. So 3E is for MVIA and the data is 03. After MVIA and the total number of T states, coming to T states, this will take 4 and this will be taking 3 in order to write. The total number of T states will be 7. The next instruction is MVIB02H. For MVI, the opcode is 06 and the data is 02. So I'll write 2002, the data is 06, and in 2003, the data is 02. After moving the instruction, now I need to perform add B. So for add B, the opcode is 80. That will be written in the next address 2004. After adding, I need to store STA2050H. Before addition, the total number of T states required for B is also same. For this it will be 4, for this it will be 3, again 7. For add B, it's a normal instruction that will be taking 4 T states. Then after STA, for STA, the opcode is 32 and it will be again written in the next address 2005. The total number of T states for just STA will be 4. But as it is 16-bit of data, so we need to split it into 8 bits. So first I am writing 50 lower address followed by higher address 20, and we'll simply terminate the program. That opcode will be 76. I just written over here 76. So this will be written in next address 2006, 2007, and in 2008 I am terminating program, say halt. So for storing the total number of T states, as I can see, 4 is for STA32, then 3 and 3 for reading lower address and for reading higher address. Total number of T states will be 10. So this will be helping to understand how much T state, that means how much clock period is being required by using a simple instruction MVI. That will be 7. Similarly for MVIB, total number of T states is 7. For addition, the total number of T states required is 4. For restoring, 10. So this is how the ALP is being written for addition. Suppose you need to subtract it. No changes, only in this. Because instead of addition, what you are doing, trying to perform is subtract. And then for subtract, corresponding the opcode will be changed. And for opcode sub B is 90. So this is way how you perform addition and subtraction for two given immediate datas. And corresponding result also I'll make sure you like understand. Suppose you are adding 3 and 2, the result should come as 5. And if I subtract 3 minus 2, the result should be coming as 0, 1. Now let us see in 8085 microprocessor kit whether the result comes or not, because using the same